What volume of oxygen measured at STP would be liberated by passing a current of 10 ampere through acidified water for 965 seconds? Hello guys, welcome to Learn Chemistry with Onye, and today we're going to be solving a question under electrolysis. And like this question said, what's the volume of oxygen that would be liberated at STP? So at STP, volume at STP is equal to 22.4 dm cube. All right, and also Faraday here, it's equal to 96500 coulomb. So the first thing we're going to do in this question is to bring out the parameters that we've been given. Current is the first parameter that's here, and current was given as 10 ampere through acidified water. So acidified water for 965 seconds. So time was given here as 965 seconds. So here's time is given as seconds, so you don't need to convert. But if time is given as minutes or in hours, you have to convert to seconds. And then we have your volume at STP. This should be a known one. It's 22.4 dm cube or 22,400 cm cube. Because to convert dm cube to cm cube, multiply by 8,000. Now, first of all, what is the electrolysis of acidified water? This electrolysis can also be called electrolysis of dilute H2SO4. So this is water having little drops of dilute H2SO4. So either sentence you see in your question would go. So we have electrolysis of acidified water. We're talking about the volume of oxygen measured. In the electrolysis of acidified water, this is one of the half equation we're going to have. So when hydroxyl is being discharged, this hydroxyl would in turn discharge oxygen. Then you have this equation: 4 hydroxyl given 2 molecules of water, oxygen gas, and this is giving out 4 electron. Now this can also act as what? 4 Faraday. So here we have IT. Whenever you hear IT, what comes to your mind? Quantity of electricity should come to your mind anytime you hear of IT. So from here, we get quantity of our electricity. This 4 Faraday here can also give us quantity of electricity. So here we have that 4 Faraday is needed to deposit oxygen gas. And we're talking about the volume of oxygen gas measured at STP. So from our equation, 4 Faraday is required to deposit 1 mole of oxygen gas, and 1 mole of a gas at STP is 22.4. So we have 4 Faraday of that is required to deposit 22.4. Now to change this to coulomb, we're going to multiply 4 by the value of Faraday, which is 96,500 coulomb. So this is going to be 4 times 96,500. It's going to give us 22.4 dm cube. Now come back to the question. We're asked what volume at STP will be liberated by passing this current through this water for this amount of time. Now, this is IT system. Remember I said whenever you hear of IT, think about what? Q. And Q is quantity of electricity. So this is 10 times 965 will give us our quantity of electricity. So you have 10 times 965 to give us our quantity of electricity, and the both of this is measured in coulomb. So what will this give? X. So from here, you're just going to find X. So what is X? X will now be equal to 10 times 965 times 22.4 times 4 divided by 4 divided by 96500. So we have 10 times 965 divided by times 22.4 divided by 4 and 96,500. So let's calculate this quickly. We have 10 times 965 is 9650 times 22.4 divided by 4 divided by 96,500. So you have 0.56, and volume is in dm cube, so this is going to be in dm cube. Now which of these corresponds to our answer? 5.60 dm cube, 0.560 dm cube, 11.2, 1.21. This, as you can see, corresponds to our answer. So when you see a question like this, how are you going to approach it? Each time you hear that of electricity of acylated water, please, this is the half equation of what is deposited at the anode. So you have oxygen is deposited at the anode, and then this is the equation. 4 hydroxyl will give you 2 water, 1 mole of oxygen, and you require 4 electricity to have this happen. Hope you got that.